Okay, here we go. Today we just have one last little concept that we're going to be covering here. We kind of introduced it yesterday. We're going to kind of come around full circle. We actually identified the problem at the end of class yesterday. And we're going to figure out how we can alleviate this problem. So the problem was when we started doing some conversion, okay, when we were going from an object variable to an interface, there was no cast. Everything was good. Everything was wonderful. The object variable to the interface, everything is wonderful. You actually have limited access from that interface. As long as it's implemented inside of that class type, you're fine. The trouble comes when we go the other direction, when we go from an interface to that object type. And really what we want to see here is if we understand the reason why. The reason why here is this. This is essentially my interface. We can be just about anywhere, but let's just say I'm in the main method. If I'm in the main method, I don't know what's on the other side of that wire. Okay? And because it's that interface type, it could actually change, and it could be a, some type sometimes, a different type another time. So this is the reason why that when you are going to go ahead and say whatever the heck this object is, if you are going to attach it with a regular object variable here, we have to go ahead and cast it. Now we were talking at the end of class here yesterday, and we found out, well, what happens if that thing over here is a circle and we try to cast it as a rectangle? That's a huge problem, okay? That will actually crash your program. So what our goal here today is obviously not crash our program, okay? So our solution here is before we go ahead and cast anything, we can actually test out what type of an object is it. Okay, so that's really what our goal is. This is our last step in our whole interface polymorphism idea. Polymorphism, that idea that that object dictates what's going to happen. Now we're going to actually be able to test what type of an object it is so that then I can further manipulate it. Okay? So the way that we're going to get this done here is very, very simply by using what's called the instance of operator. And it's very, very simple to use. We like to use it inside of a decision structure here. We just basically have an object reference, and we're simply going to say, is it an instance of something else? Okay? And typically what we've got going on here is, if it's an instance of something else, you know that you can cast it in that type. So if I had, I don't know, a thing reference, and I wanted to see if it was a rectangle, okay? If I get inside of that if statement, all right, the whole concept would be here that thing is an interface referencing something over here, all right? If that something on that other side is a rectangle, that if statement will evaluate to true. So then inside of here, you can do your cast and be 100% sure that everything is going to be good to go. Mm-hmm. Yep. And that's actually Liam's fast forwarding here about 5-10 minutes down the road. That is exactly why we're going to be needing this, is because just one object all by its lonesome pretty boring, because now we can go ahead and create collections of 1,000, 1,000,000 of these things. And if we have multiple types of objects inside of there, using that interface type, that's really where the power of this is going to be. We're going to be cycling through our collection, grabbing one of those and saying, hey, are you a rectangle? If so, I want to do this with you. Hey, are you a circle? If so, I want to do this with you. Okay? So that's really how we're going to be going ahead and using this. And once again, I know that if I make it inside of this decision structure, I am 100% safe to go ahead and cast that as a rectangle. Now, if you cast it as something else, well, then you're going to have some issues. Again, Harshan?
Can a class implement more than one interface?
Can a class I believe we can. Why you would want to, I don't know why. Okay? So there's some wishy-washy stuff between, we can only inheritance-wise extend one, but we could implement multiple interfaces if we want to.
Okay.
Okay?
And also, can we only test for a type, meaning that like we can test if something is a rectangle, but we can't have the computer spit out to us what type it is?
No, we're only going to be able to go ahead and test for that. Because there's an infinite number of types in the computer, it could be a type of an object that it doesn't even know what it is. So, yeah, that's going to be a hard one. Okay. All right, so basically what we have here once again, and this all goes back to picture, okay? We're not really introducing anything new here besides this little operator here. Everything else is exactly the same. So when you go ahead and you look at our little picture here, okay, ooh, I guess I use thing right here. Thing is an interface. It's a shape interface. On the other side here, we have an object. In this case here, we happen to put a rectangle on that. Well, what I want you to see here is, after this statement, if I'm sitting right here inside of my code, I am inside of this. Okay, so this is my main method. This is where I am. I see thing and I see a interface wire going off, but I don't have a clue what's on the other side. Okay? We can put 1,000 lines of code inside of there. I don't know what's going to be on the other side of that interface. Okay?
Technically, the length wouldn't change because it's not an instance of rectangle, it's an instance of rectangle.
Oh my!
So what we're going to do is we're going to test to see if it's a rectangle, okay? And we're going to cast it as a rectangle, okay?
You don't get it.
In order to go ahead and deal with it.
What's instance of like a rectangle?
Okay?
So aren't you like causing it something?
It's actually an operator. Yep. So, once again, inside of here, once we make it inside of our decision structure here, we know that the thing on the other side of that interface wire is a rectangle. So you can cast it and you can use it. Now, the reason why we're going ahead and casting it here is right here. I cannot use my shape interface to change the length. There's no way I can do that. I can't do anything other than what's inside of it, which is the whole reason why we wanted to go ahead and do this. We wanted the flexibility to go ahead and reference multiple types of objects, but now it came a point in time, oh, that sucks. I can't go through the filter with what I need it to be, what I need to do. So I'm going to go ahead and have to cast it as that object variable. Once we have this object variable here, okay, so if box is going to be a reference to this guy, there's no filter on that wire. I can go through with any of the method calls that are in there.
If you were going from object variable to interface, you don't need a cast.
Nope.
You still do instance of. Like, would you just put rectangle thing equals box? Or no, rectangle.
Well, you know that the rectangle is a rectangle.
Like, then you would show like things. Thing. You don't need that rectangle part.
What?
Like the thing in the parentheses, that's obviously a cast.
Yeah. So with what you said, you're absolutely right. With the first thing that you said, that if I go from an object variable to an interface, I do not have to cast. So I would never do an instance of in that case, because you don't care. Yep, because you don't care. The only reason why I'm ever checking to see what this is an instance of is so that this guy, my cast, is going to be okay. All right? That's the only reason why I'm doing that instance of, just to check to make sure that life is going to be good.
So this is just error checking? Like, if we need to cast, would you like us to do instance of every time?
I would suggest it. This is the only time we've ever casted, and in terms of our object-oriented programming stuff. If we're talking about integers or doubles, I can't ask if an object, I can't ask if a primitive is an instance of something, so that won't make any big difference. Okay? All right. So, if you want to here, programming style, as far as this is concerned, you can lump this garbage together. So this code right here is perfectly legal, but it's pretty ugly to see and understand. My suggestion is you would probably do something more along the lines of this, but if you wanted to, you can, with the right amount of parentheses here, cast this thing and then run that method. So we can go ahead and we can change things pretty ugly wise. Now I know a lot of us in this room, we're starting to combine and combine and combine things. That's fine, as long as it works. If it doesn't work, then we run into a lot of headaches here in terms of trying to get this thing fixed. But I'm going to leave it up to you in terms of how you want to do this. Remember here also, we dealt with teachers and students and persons, okay? As far as this is concerned, we can go ahead and check to see if that's a teacher on the other side. If so, I can cast it and do that. Once again, if this is not a teacher, we are simply going to skip all this stuff and keep going with my program. So if this was a student on the other end of that interface, okay, if I had 1,000 lines of code right here, and all of a sudden I got rid of that teacher and threw a student on the other end, it's going to simply skip this entire true portion of that decision structure, which once again avoids the cast, which would have crashed my program, which is the whole reason why we're after this one. Okay? So once again, you can also jam this stuff together as much as you want to. All right? Inside of a system out print line call, I'm going to do a cast to an interface and then call a method, get the results of that method, and go ahead and display it. That's a lot of stuff all at one time. Okay? You could break that up into 2 or 3 lines of code. Once again, however you want to go ahead and program it, as long as it works, we'll be happy, happy, happy. Okay?
That would crash the program.
All right. Take a little look, see what we've got here. All right? This is, when you go ahead and take the AP test, you're going to have full pages of code that you're going to need to be able to understand. In this case here, instance of is very, very, very important.
What about the brackets? Like if generator X in bracket. Oh, okay. This is my bracket.
Shoot a second about curly braces. For my if statement. No. If I only have one statement, I don't need them.
Oh, I did not know. Now I do.
Which in your programs, I would probably suggest that you write it that way, just for clarity's sake.
Okay.
So, what you want to do here is read and be able to understand my code. Instance of is super, super important in this case. Why? Because what I'm going to do is I'm going to stick a random object onto the end of that interface. I have a random number generator. Half the time they're going to be circles, half the time it's going to be a rectangle. So when you proceed from here and you start working down this code, my first block of code is going to say, hey, is there a rectangle on the other side? If so, we can go ahead and cast it, change the length, and change the width. Fine. Otherwise, down below, if there's an instance of a circle, I can cast it as a circle. All right? Once again, it's only going to do one of these blocks of code because there can only be one object on the other side. But in this case here, I actually used a random number generator. Every time I hit run, I don't know, I got a 50-50 shot of what's on the other side. If I didn't have those instances of, I guarantee it's going to crash at some point. Okay? And we want to make sure that that doesn't happen. All right. This is where Liam's question landed, all right, about 5-10 minutes ago. This is where things become super important because just one simple object at the other end of one simple interface, way too boring for us right now. We'd like to go ahead and make a collection of these things, arrays, array lists, throw 50, throw 100, throw 1,000 of them inside of there. So here I'm going to declare people as my array list here, my object variable to my array list object. I'm going to add a bunch of students and teachers, okay? In the middle of this code, this is kind of something important, all right? I said you're going to manipulate the objects. That means we can do anything, okay? Your assumption is you have no clue what that is. Maybe I deleted them. Maybe I reordered them. Maybe I put all the students at the beginning and all the teachers at the end. Maybe I killed all the teachers. I don't know, whatever you did. Okay? So, once we go to our for each loop here, now the deal is, it's a for each loop. It's not going to crash, so life is good. I can go ahead and say, go grab one of my persons, okay, so I'm going to call it someone. I'm going to ask if that individual reference is a teacher, and if they are, I'm going to get their name and display it to the screen. So my initial for each loop is simply going to go through every single element inside of my array list, grab all the teachers and display their names. Down below at the very bottom, I'm using my for each loop once again, but in this case here, I'm actually not casting anything, I'm not testing anything, I'm simply going to display the ages of every single person in there, whether they're a student or whether they are a teacher. Yeah.
So is this basically the string contains but for objects? Like I don't know how to explain it. Like contains is like yeah, like true or false.
Oh,
like
okay.
is the thing. Like this one's
This
like,
It's like the replace thing.
This is checking types. So this says you are going ahead and you have an object on the other end of this. It's going to make sure that that thing can reference it.
okay. And
Okay?
it doesn't like return like a boolean or anything.
Well, instance of is going to return a boolean. So instance of, that's my comparison operator here. Is this, if you want to think of it, equal to this? In other words, is the other object on the other side?
Sorry.
Yep.
String equals.
Yep.
Yeah. But then wouldn't you, if someone instance of teacher equals true, then you would do that?
We could do that if you wanted to, but because this is going to generate true or false, we don't need a comparison there.
Okay.
Inside of those parentheses, you just need something that says true or false. But if you want to do a double equal and say true, that would be fine.
Okay.
Yep. All right. Let's have you do a little bit of work here.
Oh.
Okay. I guarantee you've already got this somewhere. Fill an array list with teacher and student objects. All
I
right.
did that yesterday.
What I'd like you to do is add to that and simply say, have each student be out sick, as well as display the names of everyone in the array list.
3 students be out sick.
Yep.
It's a lot of sick people.
It's an epidemic.
Am I wrong? Like, the school just had like an epidemic.
Like,
Oh my god, why
Where's Black Lady?
in the black, yeah.
it's a lifestyle this year last week?
It was last year.
I think it was a new life thing though.
Is it like a nice thing though?
Yeah.
No, like yesterday. Sweet. Oh. My contact.
Your sarcastic is not
When something I say is true, this is activity 8. Something is activity. Well, that's
yeah.
why you don't
Oh,
use
I
it.
just modified. You know, when you guys like have a headache and then you have to stare at a screen because your mom made you take computer science.
Yeah, I know that.
Your mom made you take computer science.
You think I would do this voluntarily?
Yes.
Yeah, I thought you were just trying
I thought-
to get more AP from this or something.
No, I'm not.
I learned my name.
No, you did nothing. Sorry.
This is too much work. What? Why?
Okay, Snake, I'll bring you
Just
like
read it like
7
a
AP
program,
classes
like a
this
class
I'm just
requirement copy.
No, because I have nothing else to take.
Who could take French? Who could take business classes?
I
Who could
don't
take
want to
teaching
take
classes?
French. No.
They just take principles.
You do have stuff to take. You just not take.
Yeah, because none of that is interesting to me.
Oh wait, we need to use that instance.
Oh, shut up, Parchment. You're taking 7 APs and you're a sophomore.
I'm not in classes.
You are a sophomore, buddy. Believe it or not, you are a sophomore.
7 AP classes.
That's plus 15 this year.
And I'm in 20.
Nice.
Yeah, like 18.
Sarah, sometimes you just gotta be an overachiever.
My dad said that he would hire me if I learned my
Hire you? Really? He can hire you?
Well, yeah, he's the vice president.
Will he actually
what?
pay
Johnson Controls.
My dad's a cloud director for Oracle, and Oracle made
Ooh.
Java.
I never had it in teacher.
Wait, what did you say?
What?
Oh,
I was a trust fund kid.
Wait, how do you do an instant something? Anything you get? Like, I'm just gonna write the word instant. I don't know if it works.
Like, they have to use, like each one of these here, so that we can see, like,
Correction.
actually, my mom said that she would only buy me a laptop if I could computer science.
Really?
And here I am with my laptop and computer science. Oh, wait, so, do we have to do computer science? How many objects? Shut up, Vedant. I never thought I'd hear that from Vedant.
Figure it out. Oh, wait, what's it called? Like get sick or something? Is it? Oh wait, I can't do this. Those that are realists for the future and figuring how you can these
teachers can't be outside.
Wait, teachers can be.
Wait, hold on. First person. Get sick is not an instant thing with your daughter.
It's the opposite.
That's not
Wait, Evan, does your dad really not work? Oh, I didn't know that.
Of course not. That's what he said. Does your mom work?
I love that your mom, like your mom works.
Wait, what does your dad do all day?
Yeah, I know. I think that's really cool.
Why do you do all this music?
That's me when I get older. Honestly, that's kind of legendary, huh? I'm like, it's gonna like that out.
I just want to make a get sick method in person, just like a serious
No, it doesn't make sense to me. Why?
You can't imagine. This is not okay.
Why is it not okay?
It's not bueno. I know what I'm doing, but I don't want it to. I think I know what I'm doing, but not like.
We're ahead of Sarah for like 3 seconds.
Well, Sarah's
No,
like
still ahead of me. I had to make the teacher instant.
that's your problem, not mine.
Wait, shut up, but why can't I do people.get
This is
after?
Because it's not in person.
Oh,
Because you don't have it in your
so you have to update that. Not good.
He's on student loan. I don't. There's some copy faces.
Oh,
That I do for. This is so annoying. Why?
something that you would use.
If it works, it works. We don't even need to use person.
Did you have to do dogs?
By that. That's not gonna work. But did I ever work on the first question? Therefore, your argument is invalid. What the hell is that?
That's not gonna work.
Do star. Where? When she? Oh, she just. I thought you went under the table. Oh. Then just like close your eyes and take a nap, like Evan's dad.
Then there was no point.
I know. His face looks so mad.
No, it just helped me out. I just did X out sick and it like I've been thinking.
How does that work though? Oh, that's why it works though.
Yes, you did it first to be honest. I did.
Oh yeah, she did it first. Haha, get friends.
Yeah.
Actually,
No,
I
honestly, did it first.
don't know what I'm doing, let's be honest. Stay out, watch your computer. I was just gonna scream your mom. Potato.
Alright, can you give me just a second?
What is Carter's animal?
She's back ahead of you.
Yeah. But I mean, was that surprising? What? Why does that work? Wait,
Put student in parentheses and not.
I put temperate parentheses.
Okay, let's look at our solution. So, the whole idea here was checking to see if we have a student, okay? Our first for each loop here. And once again, you can write these as standard for loops. I don't care. But then you have to go get the object, then you have to go ahead and deal with whatever you got. In this case, our for each loop is really nice. Once again, that whole idea of the manipulation, I may have deleted everything out of here, okay? I want to make sure that I don't go off the bounds of my array list. So once we go ahead and we check it, we have to cast it because out6 is not part of that person interface. It's not inside of the filter. It will not go across. That's why we had to go ahead and cast it as a student to give myself more flexibility to get done what I wanted to get done. The second for each loop down there, all right, get name, that was part of my interface. I didn't have to go ahead and cast anything. So this was kind of a nice piece here. I would like to use my interface if I can, but if I can't, then I'm going to have to go ahead and deal with it in a different way. All right. Let's add a little bit to this thing. What I'd like you to do is I'd like you to go ahead and pay each teacher and display the name of the students in your array list.
Like Evan's dad.
Alright, that's enough.
Oh, great. That's all I wanted to do. Sorry.
You should be. Okay then.
So someone is in a final.
Just the last one.
What is your O? What is going to be?
The assessment's going to be.
Oh, okay. Thank you. You asked this
Not asked.
I know.
But it's
Maybe you
indicated.
don't ask, you don't have it.
Yeah.
You don't ask.
That's not my
It'll annoy me enough where I don't give it to you. Really.
Which one is
I must say that's pretty bad.
It's fine. Mr. O just hates us all. Like it's okay. I'm not mad.
I hate you both.
Okay.
He hates me more than
You're
most.
not special.
Oh, he is. He hates him more than most.
Ooh.
Therefore, it meets the requirements of whatever. You're welcome. I don't know what you just said. Something.
Yeah. That's okay.
I do that a lot.
What did you say?
what?
You know what? Where is this thing? It's called outsick. That's why nothing ever works.
Also, you.
You're alive.
Why are you like?
It's called get sick. Not so. It's called outsick, not get sick. Yeah, I did get sick.
Why do you have this?
What do you mean?
Is yours more updated or something?
No. Mine just sauce. Much sauce. Much sauce. Wow.
All right, let's talk about our solution since it was about 5 lines of code.
Yes.
So, once again, when we go ahead and we take a look up here, okay, our first for each loop, we're going to go through, we're going to pay all the teachers, so I need to go through my array list, find all the teachers. Once I have one, I cannot use my interface to go ahead and give them arrays, okay? That's not able to do. It is my second for each loop, right?
No.
What names did I give you?
Oh. Gave us distinction. It's not a person.
Oh,
Is it?
yeah.
I'm confused. I quit.
Okay, so you're absolutely right. So if I was only supposed to give student names here, my second for each loop is wrong. But is that system out print line? Will I be able to display everybody's name? Does my interface allow that? Okay. So really all I need to do is add a little check inside of here. So if I've got someone... All right, what are we looking for, student? All right. If I added in that line of code there, that would make everything all that much better because now I can go ahead and check if they are a student. So in this case, I checked to see if they were a student. I didn't need to cast that reference because all I wanted to do is display their name. So in this case, I checked to see if they were a student, and only the students did I go ahead and get their name, but I used that interface reference. So I didn't have to do all that work. Could I have cast it as a student? Sure. But in this case, you didn't need to because it was part of your interface, your filter. Okay? So what we've got here is basically a bunch of programs for you to write. Okay? And that guy's not in here anymore. Okay? All of these different programming opportunities are listed out on Google Drive as well as your sample assessment. Okay? Now, I do want to talk about your assessment since so many people want it to happen real soon. Your sample assessment is basically going to be 4 pieces. You're going to have at least 4, maybe 5. I got to check on that. Oh.
All of the above.
So when you go ahead and you look at preparing for this assessment here, you're going to have a couple class definitions that you have to write. The class definitions are not meant to be overly complicated. So when you go back and you look at like car or something like that, no, that's like way too complicated. All right. Is it going to be as simple as circle and rectangle? Maybe a little bit different than that. Okay. But way closer to circle and rectangle than car. So if you're looking at just that class definition, it's going to be a couple fields, throw some simple data in there. That's about it. After you write a couple class definitions, you are then going to have to write an interface. That interface is going to be implemented for all of your classes that you write. So you got a couple classes, then you have to write an interface. Once we have all those things set up, then you're ready for your last part, which is you are going to create a test class. That test class, believe it or not, you're going to go ahead and stuff a bunch of objects into an array or an array list, and you're going to manipulate them for me. Okay? Very, very similar to all the activities that we literally just got done doing. So, if you look at everything that we did here, we had circle, we had rectangle, we had teacher, we had student. That's your first part. Second part, generate your interface. We generated shape, we generated person. Third thing, write your main method, stuff a bunch of stuff inside of an array list or an array, and manipulate it. Okay? Okay. Great question. So on this here, there is some stuff left over from designing classes that I promised would show up. You must also know toString, equals, and clone. We need to be able to write those. Okay? Lastly, you will have to do a static field numbering.
Oh no, what that?
Okay, so Gabe, you're absolutely right. We will just need to be able to do that individual numbering, like employee 1, employee 2, employee 3. Okay. Yep. So we've got some class definitions included in those class definitions. ToString, equals, and clone will be a part of them. Also, your static field will be part of it. It'll just be simply giving a unique number to your different objects. You're going to have your interface that's going to overlap all of your different classes, and then your test class. No sorting. No sorting.
I can do searching, linear searching.
All right, we got about 40 minutes here. Plenty of time for you guys to go ahead and get cranking on these things. Lots of stuff available for you to do.
So you like explain what would be